Hi, welcome back. Certainly glad you could join me today. I thought today we'd do a fantastic little Java project. Just a simple little painting exercise that I think you'll really enjoy doing. If this is your first time with us, let me extend a personal invitation to you to drag out VS Code or your favorite Java editor and code along with us. Or just drag up the old easy chair and enjoy relaxing with us for the next half hour. And if this is your first time coding in Java, I've got a handy little guide that will get you all set up in less than 10 minutes, linked in the description. Today we're going to be using the Java Swing library to make ourselves a little painting. I've already primed our project with an empty class and a simple main method. And the first thing we need to do is to create a window for our canvas to live in. With the Java Swing library, we can do that using JFrame. So here's your bravery test, right at the start. Ready? Time to write your first line of code. We're going to create a variable that represents our window. And the data type of that variable is going to be JFrame. And then you can name your variable whatever you like. I'm going to call mine window, but you might call it frame or something else, but keep it sensible. You don't want to use Pokemon characters for your variable names. You'll thank me later. Okay, now we need to assign some data to our variable. The equal sign is our assignment operator, and we're going to create a new object of type JFrame. And end it with a semicolon. Most statements in Java end with a semicolon. Let's look at this line of code we've written, and shoot, VS Code is unhappy with us already. We know it is because we've got these little red squiggly lines underneath JFrame. Those little rascals, you'll learn to love them. If you hover over one of them with your mouse, you can see the error message. JFrame cannot be resolved to a type. This is saying that it doesn't know what we mean by JFrame. What we need to do is import the JFrame class. So we could type that import in at the top of our file, above the class definition, or we could use the quick fix feature of VS Code to do it a lot faster. Just click somewhere on the word JFrame so your cursor is there, and then press Ctrl period to open up the quick fix options. Here it asks if we want to import JFrame from Swing, or create a class named JFrame, or maybe we had a misspelling and we meant to write job name. In this case, we certainly want to import JFrame from Swing. There. The import has been added all nice and neat for us, and those red squiggly lines are gone. Now we've got this yellow squiggly line, but that's okay. That's just a warning, not an error. It's just telling us, hey, you've got this variable, but you're not using it anywhere, so you might want to check that out. But of course, we'll be using it in a minute. Alright, let's speed things up a little bit so we can get our window open and move on. Let's give our window a size. So on the window object, we'll call the setSize method, and we'll give it the width and the height that we want in pixels. I'm going to set mine to 900 by 600, but you choose any window size you want. Remember the semicolon. And now to show the window, we'll call window, and we'll call the method setVisible, and we'll pass in true. Okay, let's run this to make sure that everything's working. Just like so. Now then, when you close your window, you'll see in your console that your program is actually still running, and that's no good. So in the console, press Ctrl-C to close the process. Terminate batch job? Yes. Let's prevent that from happening. So back in our code, make a call to setDefaultCloseOperation. And I'm going to do this first thing after initializing our window object. And we need to tell it what the default close operation should be. So here, I'll pass in JFrame.exit on close. This will exit our program when the window is closed. Now this bit of code, when you read it, it's a little bit confusing. So this is a great place to leave a comment and remind ourselves what this is doing here. Test your code often. Isn't that just gorgeous? The process ended when we closed our window. And you might be asking yourself right now, how did he know to write that bit of code? Well, someone told me. Now then, we need to add a canvas to our window, something we can draw on. For that, we'll use another swing component called JPanel. Now things are about to get a little hairy, but stay with me. You can do this. Anyone can do this. We need to add a JPanel to our JFrame, but you know what? What the heck? Let's just do that. We want to show our window as the last step, so I'll move that to the bottom. And in here, let's create a JPanel object. I'm going to call mine canvas. And of course we need to import it using our little trick. And then we'll call window.add and we'll pass in our canvas object. Ain't that easy? Now I wish it were as simple as adding graphics to our canvas from here, but this is Java after all, the land of object-oriented programming, and it doesn't take long before you need to understand a little bit about inheritance. JPanel has this method called paintComponent, and we need to override that method to draw our graphics. You know, it's always a balance when I create these tutorials, between keeping things as simple to understand as possible, so I don't scare you all away, but still teaching you the proper techniques, the best and most powerful ways to do things. Anywho, to do that override, we could create an anonymous inner class. We won't do that, but let me show you what I mean. Because what the heck? In Java, when you create a new instance of a class, you can overload methods on that new object without having to define a subclass, just by adding some curly braces between the constructor parentheses and a semicolon. Then in this space, you can override anything that you want. So I can define the paintComponent method here, add the override annotation, call super on it, and all that sort of stuff. But let's not do it that way here, because that's a little messy. Let's do it the more explicit way, where we do create a subclass of JPanel. So you can define this in a new file if you want. When you have large projects, it's definitely a good idea to put classes each into their own file. But for this exercise, to keep things simple, I'm just going to define our new class in the same file. So let's go down here to the bottom, and we'll create a new class, myCanvas, that extends from JPanel. Again, you can call your class whatever you like, but I've called mine myCanvas. And a question I get asked all the time from people is, why don't we put a semicolon after the curly braces here? Well, when we're defining a class or defining a method, we don't put semicolons there. Also, loops and if statements don't get semicolons. The anonymous class I showed you earlier did get a semicolon after the curly bracket because while we were defining it, we are also assigning it to a variable. There isn't really any rule of thumb I can teach you so that you'll always know when a semicolon is needed. It's something you pick up over time with practice. And if you're not happy about it, well, maybe someday you'll write your own programming language with its own grammar, and wouldn't that be wonderful? So now we've got our class defined, and even though it's still empty, let's go up to our main method and use it. So the type of canvas instead of JPanel will now be myCanvas. Now I want you to run the code here because we've got a subtle bug that I want to talk about. Here I've created a simple image in Paint and I've sized it to 900 by 600 pixels. And this is the same dimensions as my window. And if we drag our window over, you'll see that our window is actually much smaller than the reference image we've created below it. That's because when you call set size on a JFrame, that includes the title bar and the borders and even the shadows around the edges. But we don't want that. What we want is for our actual canvas size to be what we defined. So let me show you how to do that. Let's get rid of set size. And while we're at it, we can give our window a title just by passing a string as the first parameter in the JFrame constructor. So you indicate that it's a string by using double quotes. And I've called my window art. Now we need to set the size of our canvas. The method for that is setPreferredSize. So we can either call this on our canvas object, and we can do it just before we add that canvas to the window, just like this. Or I'll tell you what, let's create a constructor for our myCanvas class. And we can call setPreferredSize from in here. Now if you do it this way, every time you create a new My Canvas, it's always going to use this same size. So it's up to you if this is how you want it to work or not. If we write 900 by 600, so we're passing those in as the parameters to set preferred size, you can see that we've got an error. And if we hover over it, I see that parameters is in bold. And look at the method definition. It expects only one type of parameter of type dimension. So we need to pass in a dimension object. You could create a new variable for this, but we can also do it inline inside of these parentheses, just with new dimension. And then that dimension class does allow us to type in the width and the height as integer values. And we need to import dimension from Java AWT. Okay, still with me? Now back in main, after we add everything to our window, but before we show it, we need to call window.pack. This little method will wrap our window around everything that we've added to it. So since our custom JPanel is 900 by 600 pixels, our frame, after we call pack, will just wrap around it. And it's not real obvious from our code that that's what's going on here, so be sure to add a comment to clear things up. So let's run our code. And compare this window to our reference image again. And you can see it does appear that our canvas area is now the size that we want. Okay, you're doing great. And as you come back to the code, let's just look at it for a minute. You know what I'm seeing? Not enough comments. Remember, we spend more time reading code than we do writing it, and you read your own code more than anyone else's. So do yourself a kindness, make it readable. While I was doing that, I also added a couple more lines of code, just to make our window a little bit nicer. Set resizable false prevents our users from resizing the window, and set location relative to null will start the window out in the center of our screen. And of course I've noted this in the comments. Okay, now what? I'll tell you what, I think it's time to paint. Let's get started by covering our canvas in a thin even coat of liquid white. And by that I mean, let's set the background to white. Back in our constructor for my canvas, we can call a method called setBackground. This method belongs to our parent class, JPanel, just like setPreferredSize does. And the argument that we pass in to setBackground will be color.white. Now when I go to import color using the quick fix that I showed you earlier, it gives me a ton of options, but none of them are actually what we're looking for. So we'll need to do this import manually. If you hold Control and click on Set Background, this will open the source code for Set Background in another tab. And if you hover your mouse over color, it'll give you the details on the data type that it's expecting here. And here you can see that it's java.awt.color that it expects. So that's what we need to import. So let's type this in. You can put this wherever with the other imports. I like to keep mine alphabetized. And when we run our program, you can see that the canvas is now completely white. Now we're ready to override the paintComponent method. Remember that little rascal? I'm going to steal the method header for this by opening up JPanel using Control-click. And then we'll need to go to the JComponent source. And here I can search for paintComponent. And this is the method that we'll be overriding, so I can go ahead and copy this header. And I'll paste this into our MyCanvas class. And in the body of the method, I want to call super.paintComponent. That way, if there's anything important going on in the parent class, that code will still execute. And we need to import the graphics class. Again, this isn't recognized by quick fix, but I know it's a part of Java AWT from the source code that we just looked at. Shoot, you know what? Let's save ourselves a little bit of time. Up in your imports, instead of importing each one of these things individually, let's import the entire Java AWT library and also the entire Java Swing library, because we're going to be using these components a lot, and I'm confident that none of those class names are going to conflict with our project. So you can just use these little stars or asterisks to import everything in a given package. Now back down in paintComponent, and this step is optional, but I always like to mark my overloaded methods with the @override decorator. This just helps me to see at a glance that this method replaces something in a parent class. There's a lot going on here, isn't there? But don't worry, anyone can do this. All it takes is a little time, a little practice. Anything that you're willing to practice, you can do. And you know what? I think we're finally ready to start painting. Let's go into paintComponent and let's draw a sky. Wouldn't that be nice? So all I'm going to do is set my color. The graphics class has a set color method on it, so I can call that on my G object. Let's start with blue. And then we're going to draw a rectangle that's this blue color. So still in that same graphics object, I'll call fillRect. And this should give us a rectangle that's filled with our color. And this takes 4 arguments. The first 2 are the X and the Y coordinates of the upper left-hand corner of our triangle. I want my sky to start in the very upper left corner of the canvas, which is 0, 0. In the Java Swing library, their coordinate system is to have the upper left corner as 0, 0, and the bottom right corner will be the width and the height that you gave your canvas. So in my case, that would be x equals 900 and y equals 600 for that bottom right corner of the canvas. So the next 2 arguments are the width and the height that I want for my sky. Well, I want my sky to span the entire width of the canvas, so that'll be the same as the canvas width, which is 900. And for the height, well, that can be whatever you want it to be. I'll choose, I don't know, maybe 220. Something like that. Don't worry about it too much. You can always change it later. And let's see what this looks like. Hey, pretty good. I think we've got something here. But maybe that sky color isn't quite right. Maybe we want something a little bit lighter. This color.blue, that's just a constant defined in the color class. Let's use our control-click trick to look at that. Here you can see all this is a new color object that has the red, green, and blue values set as integers. So we can use this to create our own colors as well. So I'll copy that over. And I'll put it in set color. And now I can change these RGB values to anything I want. So you could guess what numbers might add up to light blue, but heck, I don't know what that is, so let's look it up. You could use something like the Paint program to find the RGB value of a color. Or what I like to do is go to Google and search for color picker. And here you have a wonderful little tool that'll help you pick out the color that you want. And when you're happy with it, all you have to do is copy that RGB value and paste it into your color constructor. See how easy that is? And now we've got this nice sky color. I know this project might seem a little frivolous to you, but if you're interested in making games, being comfortable with 2D graphics is so important. So important. And doing a little project like this is a great way to get comfortable. You know what? Let's put a little light source in this painting. Still in paintComponent, after we've drawn our sky, let's add a yellow sun. So I'm going to set the color to yellow. And I'm using one of the constants here, but feel free to make your own color, just how I showed you. This is your world. Do what makes you happy. And now I want to draw a circle, so I can guess that maybe that's called fill circle. But there's that squiggly red line again, that little rascal. And it's telling us that fill circle is undefined, so let's find out what methods are available. I've already shown you how you can look at the source code to find out more about a class, so why don't I show you another way to do it this time. Let's read some documentation. And I want you to stop and think for a moment about what you would search for in Google to find this documentation. What I would search for is Java, graphics, fillRect. Java because that's the language that we're using, graphics because that's the class name that we're working with, and fillRect because I already know that this is a valid method on this class, and I suspect that any fill circle documentation is going to be very near to it. The first result that we get looks very official, so let's try that one. And here you can see that this is the official documentation for the java.awt.graphics class. and it lists out all of the available methods for this class. Let's search the page for the word circle. And it brings us to draw oval, which sounds like it could be what we're looking for. If you read this summary, it does mention that you can draw a circle with it, but it will only draw the outline. But just below it, I see fill oval, which is exactly what we're looking for. So we're going to give this an X and a Y, not of the middle of the circle, but of the upper left-hand corner of the rectangle that bounds it. And then we give it the width and the height of that bounding rectangle. And look at that. It really brings you back to kindergarten, doesn't it? Now this is important. The way that these graphics are rendered is, anytime we add a new graphic, it's drawn on top of the graphics that we've already added. So we have to work from the back forward as we build our scene, just like in a real painting. To see what I mean, let's try moving our sun code before the sky code. So the sun will be drawn first, and the sky will be drawn second. So now you don't see the sun because that circle is behind this blue rectangle. Ooh, sometimes I get carried away. I see something here. Now you can continue like this and you can keep adding more and more graphics in paintComponent, but I think we all see where this is going. We're going to have a complete mess inside of this method by the time we're done. So let's do something about that. Now this is where it gets fun. We have so many options, so many possibilities for organizing our code. This is your chance to fire up your imagination, really decide what makes sense to you, what feels right for this project. You know what I'd love? I'd love to show you how to create and use your own class. Wouldn't that be wonderful? Maybe right up here lives, yep. There's an object here that we'll use to do our painting. I'll call it a paintbrush. I think that's one word. Maybe it's two. Heck, I don't know. And so I'll call this paintbrush object my brush. And I'll initialize it. And I'll pass over the graphics object. There. Now we need to define this class that I just made up. Again, you can do this in a separate file. That's not a bad idea. But to keep things simple, I'll just add it below here. Make sure you're not inside of any other curly braces. And let's create a constructor that will accept that graphics object. And I'll actually call the graphics that's coming in graphics. Again, that's just a variable name. You can use whatever word you want. And we need to hang on to this graphics object inside of a private member variable. So this way, any methods that we write inside of our paintbrush class are going to have access to this graphics object. Now let's move our code that draws the sky into a new method on the paintbrush class. I'll call it drawSky, but again, you can call your methods whatever you like. And I'll move that code over. Make sure that the name of the graphics variable that you use here is the same as your private member variable. And now we can do something magical. In paintComponent, after we've created our brush, we can now call drawSky on it to execute all of the code inside of that method. And when you run this, the output should look just the same as it did before, but now we're more organized. I think we need some mountains in our painting. And now we have so much creative power. Look at that. It can just happen for you. We can just go ahead and call mybrush.drawMountains. Just make it up. Whatever you want in your paintbrush, you decide. You decide. We just need to define what draw mountains means. So we'll make it public. And that just means that we can use this method outside of the walls of this class, which is what we want because we want to call it from paintComponent. And we'll set the return type to void because we aren't returning any data from this method. And then we'll write the name of the method. And we won't put anything inside of the parentheses because we aren't asking for any parameters. Now mountains are jagged, so we need a way to draw something jagged. And in the documentation, I noticed that there's this method called fillPolygon. I think that'll work. As always, we'll start by setting our color. There isn't a color.brown, so we'll have to create our own. And you know what? There are certain colors that I like to use a lot when I'm painting. So why don't we go ahead and define those as constants in our class. Okay, I've set up all of my colors as class variables on the Paintbrush class. I've got phthalo blue, cad yellow, alizarin crimson. I've declared them final because their values won't be changing. And I've declared them private because I'm not going to use these colors anywhere outside of this Paintbrush class. I've declared them static as well because these values won't change between different instances of the Paintbrush class. You could leave off all three of these modifiers and your code will work just as well, but it's a good idea to get into the habit of using them so that you can start to understand what they mean. I've also put these names in all caps because that's a common convention we use for variables that store a constant value. This makes it easier to read our code later, and I know you get tired of hearing it, but pay attention to that code readability. It's so important. Now in Draw Mountains, I can set that color to Van Dyke Brown. For our first mountain, let's just draw a simple triangle. To do that, we'll create a new polygon. I'll call mine Triangle. And then we add 3 points, one for each vertex. Something like that. Then we can use this triangle object to pass into Fill Polygon. And just that easy, we have our first mountain. Shoot, this is so much fun. Let's get crazy. Let's give him a friend. Maybe with multiple pointy tops on it. I'll have 5 vertices in my polygon, but remember, don't just add another point because I did. Put one in your painting because you want it there. And you might be wondering, Ben, how am I supposed to figure out what all these coordinates should be? Do I just picture a giant grid in my mind and count over so many columns and rows? Well, I think that is probably a good idea to practice visualizing. But let me show you a little trick I've been using. If you open up Paint again, or any other image editing program, and set your canvas size to the same as our canvas, and then draw a simple shape that you want. Now when I hover over any of these vertices, you can see in the lower left-hand corner what those coordinates are. I think maybe I'll move that first mountain, the background mountain, over to the left a little bit. Now if you don't pick a different color for your two mountains, they're going to bleed into each other. It would look something like this. So we need a lighter color to give that sense of separation, but you know, this dark sienna doesn't look that great either. What if we could mix colors, just like a painter does on a palette? Figuring out how to blend two colors would be a challenging project in itself, and heck, maybe someday you should go back and do that sometime. But to move this project along, I'm going to search for a solution on Stack Overflow. And sure enough, that didn't take long, did it? I found this nice blend method that takes two colors and a blending ratio, and it returns a new color. And looking through this code, it doesn't look like it's going to install a virus on my computer, so what the heck, let's try it out. There are no mistakes when copying from Stack Overflow, only happy little accidents. So to use this, I'll create a new color variable, and I'll call it Mountain Mix. And I'll blend some Van Dyke Brown with some yellow ochre at a ratio of 15% yellow ochre. And you see we've got one of those little rascals here. The final parameter needs to be a float, so we need to put a lowercase f after that number to indicate that this value is of type float and not double. Because again, this blend method is requesting a float. And of course we need to use that mountain mix when we set our color. And now you can see we've got this lovely color for our foreground mountain. We can't have a happy little painting without a happy little tree, can we? So let's add a tree. Here you might choose to pause the video and try drawing a tree yourself. I'm going to be using a loop, so see if you can't somehow use a loop yourself. And when you're ready, we'll be here. Okay, let's call my brush .drawTree. And then in the Paintbrush class, we'll create that drawTree method. I want to start with the trunk because that's going to be hidden behind the leaves. And here, what the heck, let's mix together 3 colors. So we've got Van Dyke brown, some dark sienna, and a little bit of cat yellow in this mix. And never be afraid to run your program to see what you've got. Wonderful. Now let's draw some leaves. We'll start by mixing some sap green with some phthalo green, and we'll set that as our color. And the technique I'm going to use here is, I want to draw several triangles in a line from top to bottom, where each triangle, as it gets lower on the tree, it gets a little bit wider. Of course, I could draw those by defining each shape individually, but let's get a little bit clever here. Let's use a for loop. Here I've created a classic for loop, where the iterator variable I will start at 0, and it will increment by 1 each time through the loop. And it will continue until I is no longer less than 5, at which point it will exit the loop. And each time through this loop, we'll be creating a new polygon, and we'll be adding it to the canvas. So that's the code you see here. Now let's think about the top of our tree, just that first triangle. And let's just code in the top point with a fixed value. For me, I found that 803 by 310 is just about where I want that to be. Now let's do the bottom left vertex. We know the vertical coordinate, the y coordinate, is going to be 310 plus whatever we want the height of our triangle to be. So if we wanted our triangle to be 50 pixels tall, this would be 360. But instead of hard coding this as 360, let's say it's 310 plus whatever we want the height of our triangle to be. So if we set this height variable equal to 50, now we know that 310 plus 50 is going to evaluate to 360. And we know we want to use the integer data type here because we're dealing with whole numbers. We can even start to think about the next vertex because we know the bottom right will have the same y value as that 310 plus height. Now we just need to figure out the x values of these bottom vertices. Well, let's say that we want this top triangle to be 70 pixels wide. Let's create a new variable for that. And we want our top vertex to be right in the center of the triangle. So we intuitively know that this left vertex needs to be 35 pixels over to the left from this top triangle vertex. And this bottom right vertex needs to be 35 pixels over to the right from the center line of the top vertex. 35 is half of 70, so doing this will put the top vertex right in the middle. So you could take this 803 minus 35, which is 768, and you could put that in as the x value for the bottom left corner. But it'd be better to write 803 minus 35. And for the bottom right corner, that would be 803 plus 35. And by doing it this way in the code, it makes it more clear what we're doing. But where does this 35 come from? Of course, that's half of 70. So instead of writing 35 here, why not write width divided by 2? And then the same below. Now you've got a more dynamic algorithm, and I'll show you the benefits of this in a minute. Now I'm about to run the program here, but before I do, I want you to stop and think for a minute on what's going to happen. Think about how many times we're going through this loop, and what's going to happen each time. So we see one triangle here, but actually there are 5. Each one is stacked on top of the other. Because each time through the loop, we drew another triangle using the same coordinates. So what we want is, each time through this loop, we want to move the next triangle down a little bit. Let's make another variable for how much vertical spacing there should be between each triangle. And moving things down is a y coordinate shift, so we're only going to be changing the y. And each time through the loop, we'll need to add more spacing. So you might be tempted to just add spacing to each y value. But if you think about what this does, it's just going to add those same 15 pixels to every vertex, shifting the whole thing down. So it'll shift all of the leaves down equally. Instead, we need to incorporate this I value so that the amount changes each time through the loop. If we instead add spacing times I, think about what that does. The first time through the loop, when I is 0, spacing times 0 is 0. So no spacing will be added. The next time, I is 1, and 1 times 15 is 15, so 15 pixels of spacing will be added. The next time, I is 2, and 2 times 15 is 30. So 30 pixels are added, and so on. So now when we run this, we get this nice stacked effect that we're looking for, and it's even starting to look like a tree. See, math isn't so scary. Or maybe it is. Let's see if you can figure out this next one. Remember I said I wanted each triangle to grow a little bit as we work our way down. How do you think we'd do that? Well, the positions of the top points won't change, but the bottom corners will need to be expanded down and out by some growth factor. Let's create a variable to control that growth factor, and we'll make it a float because it's a decimal value. Or you could make it a double so that you don't need this ugly f at the end if you wanted. So here I'm saying I want each level of branches to grow by 26% each time through the loop. But it won't just do that. We need to tell it to by writing the appropriate code. And we know this top isn't changing. And let's give ourselves some room here to do more math. It's perfectly fine to break up your code like this when you need some more room. So what happens if we multiply the coordinates of the bottom 2 points by rate? Well, if you work out the math with some examples, you'll see that it just shrinks those values. So a position like 768 by 360 would become 199.68 by 93.6, which is completely out of whack. What we really want to do is multiply the coordinates of the first triangle by 1 so that they don't change, and then the next coordinates by 1.26 so they grow slightly larger, and then the third loop by 1.52 because we added another 26% growth, and so on. And this formula here for growth will do that. If you don't believe me, you can work it out on paper for yourself. I don't mind. So let's run this and see what we got. Now this is my favorite part. When an error pops up like this, the first thing you're going to want to do is take all of your doubts and feelings of inadequacy and just beat the devil out of it. Wasn't that fun? Now look again at this error message and find the line number. Right here. You can even just click on it and it'll bring you to the problem. And here the message is saying that we're passing in float values, but this method expects integers. And this makes sense because the pixels on your screen are indivisible whole units. So we need a way to convert our float values into integers. And there's a common function for that, math.round. So we can just wrap our whole calculations in this method call. And it's so common, we don't even need to import anything. And with that, we've got ourselves a happy little tree. Now I'm going to move on, but if your tree needs a few friends, you should absolutely go right ahead and do that. Maybe you could even create another loop around your calls to draw tree and draw a whole grove of them. That'd really be something, wouldn't it? Think about what sort of parameters you'd need in your draw tree function to do that. Okay, I know the old clock on the wall is telling me it's getting late, but there's 2 more things I want to show you. I think our painting needs a little grass, don't you? And to do this, I want to use a gradient to create the illusion of distance. So we're way back up in paintComponent, and let's add a call to draw grass. And in the paintbrush class, we'll define this method, and we'll mix up some color. And we need 2 colors this time, one for the start of the gradient and one for the end. And now we need to make a gradient out of this. And for that, we'll use the gradient paint class. And this is just another tool in java.awt. And in the first 2 parameters, you set a key point for your first color. I'll use 0, 0. And then you give it your first color. This will be the color that appears at the top of our grass, so it'll appear more distant. Let's get some more room here. So then you set the key point for your second color. I'll use 0 again for the X, because I don't want the color to change from left to right. But I'll put in 500 for the Y. So this way, the first color fades into the second over the span of 500 pixels. And it'll do so in the vertical direction. And finally, we give it the last color. Now then, we've got a gradient all ready to use. But if we try to pass our gradient into set color, we get an error, don't we? This method only takes a color type value, not a gradient paint. To use this gradient, we need to move on from the world of the graphics class and into graphics 2D. Fortunately, it's pretty easy to create a graphics 2D object from our graphics object just by casting it. The graphics object given to paintComponent in JPanel is secretly also a graphics 2D object, which is a class that extends graphics. So we can tease that out just by putting parentheses graphics 2D in front of it. You may think this casting thing doesn't come up very often, but in Java, believe it or not, it really does. So it's good to get comfortable with it. Now that we have this graphics 2D object that I've called G2, we can call setPaint and we can give it that gradient paint. And then we can call fillRect to draw a rectangle, just like we do with the sky. Just like so. And when we run it, the gradient looks good, but we've covered our mountains. Let me show you how easy that is to fix. Remember, we need to draw graphics from back to front, because each new graphic is placed on the ones that are already there. And remember, our main controller for this is all the way up in paintComponent. Now, because we got ourselves organized, we can just move this draw grass to happen right after we draw the sky. There. Shoot, we just about have a finished painting here. Now I want to do just one more thing, one final touch up before we go. This last step, I'm going to call finishing touches. And that'll be the last thing that we call in paintComponent. And it's going to be the last thing I'll add to the Paintbrush class. So here I've defined it, and I want to show you how to draw an image on your canvas. So first you'll need to find an image file that you like, and you'll want to put that in your project folder. Now inside of finishing touches, we want to read that image file into a variable. This data type will be a buffered image, which you'll need to manually import from java.awt.image. And for the variable name, I'll just call it image. And to populate this value, we'll call image.io.read. Image.io you can import from javax.image.io. And then this method wants a file object. So we create a new file object. And in the constructor, we pass in a string that is the path to our image file. And because this image file is in our project folder, we can just give it the file name with the extension. And of course, we need to import file from java.io. And now you might be seeing this error, unhandled exception type, IO exception. Whenever we're reading from the file system, there's a chance that something could go wrong. And if that happens, it will generate an exception. In this case, an IO exception. And to deal with exceptions in Java, we use a try catch block. So you put the code that you want to execute inside of the try block. The block is just what's in between these two curly brackets. And then we'll catch an IO type exception. And you can give that exception a variable name. And so if any of the code in this try block throws an exception, it will stop running the code in that try block, and it'll start running the code in this catch block instead. So I'll remember to import IO exception. And then I've just written some code here that will print out a message to our console if there is any exceptions reading the file. But if our image does load successfully, we can use that to pass into graphics.drawImage, which will draw the image on our canvas. And I'll use 0, 0 as the anchor point to match the upper left corner of the image to the upper left corner of our canvas. And we don't need any image observer, so we indicate this by putting null. And if you want to know more about what null means, I'm going to invite you to consult another video, because this is our last line of code today, and I'm just excited to see what we ended up with. Look at that. Isn't that just gorgeous? I really hope you tried this one, because as I said at the beginning, this really is a simple project that you can do even if you've never coded before. And remember to make it your own. Don't be afraid to try new things and see just how far you can take it. I'd love to see what you come up with, so if you don't mind sharing with us, I invite you to post your paintings on Twitter with the hashtag #JoyOfCoding. So I hope you really enjoyed it, and I look forward to seeing you again next time. So from all of us here, happy coding, and God bless.